So, hello student. So, today we will continue the second lecture on biological treatment, okay, biological transformation, that is we are discussing on composting. So, and this lecture will focus on to factor affecting the composting process. In the previous class I was talking about the composting is a purely a biological decomposition process and purely depend upon the microorganism, and the major microorganisms are bacteria, actinomycetes and fungi. So, obviously these are the live organisms. So, obviously there are a lot of factors will be affecting their growth, their degradation process, like such as you take the example of human beings or animals. We have a lot of issues about like climatic conditions, we need water, we need food, and the climatic condition is a major issue, like in the coldest day we have different factors which is getting affecting to us. So, similarly in the composting process also these microbes will be required, the particular parameters need to be considered, not only the physical one, but also with the kind of food, how much moisture content will be required, or how much is the water will be required for their growth, and what kind of substrate could be possible to degrade by composting process. So, we will go one by one factors and we will discuss. So, the first factor is a temperature, and obviously this temperature is a ambient temperature, and because of ambient temperature there are lot of changes onto the growth of microorganism, and obviously at lower temperature the growth of bacteria or growth of microorganism will be very slow. At higher temperature like 30 degree, 40 degree ambient temperature, the growth of microorganism will be very high, and you know that in the composting process also itself the temperature is rising in the organic mass. So, this is one of the important one. Well-being and activity of microbial population is one of the major factor, and you see that the curve of composting process efficiency speed pattern between 35 to 55 degree centigrade are negligible at temperature above 70 degree centigrade. Okay. So, it is the temperature in the mass, composting mass, and at temperature higher than 65 degree centigrade most non-spore forming died off and spore forming enter the spore stage, and the maximum amount will be the spore forming bacteria. See, this I am talking about the temperature inside the composting mass or organic mass or organic fraction of MSW, where temperature is rising. And the previous class also I was talking about when the temperature is rising more than 60-65 degree, where these all pathogens will be died off, and those pathogens will be mostly a non-spore forming bacteria, and those are very important for the degradation process. Those will be the spore forming bacteria, and they will be available in the passive way, and once the temperature will lower down, they will be again start to degradation process, and their growth also could be possible. So, again the in the photograph it is showing that the monitoring of the temperature. So, in the similar way the composting process, again the raw material will process for the composting process, the water vapor will come out because of temperature, heat will come out, carbon dioxide, because that carbon will get degrade and convert into the carbon dioxide will come out, and finally we will get the finished compost in the presence of the microbes. Okay. And this is one of the studies says that, see here the temperature graph. So, here you are saying this is the ambient temperature graph, and now here the composting mass has been increased like this. So, is one of the example, temperature is very high, thermophilic temperature, and again the temperature has been dropped down, and finally it come to the ambient temperature is similar to the ambient temperature. Okay. So, is again depend upon the ambient temperature. 30 to 35 degree centigrade is one of the best temperature for the degradation process. Okay. There not only the maximum degradation could be possible, but also the growth of bacteria or other microorganism will be very high in this temperature. Now, here this question will come up, sir, if this temperature is best temperature, so what will happen in the cold temperature, where temperature reduced to 10 degree, because in India the temperature difference is very high in the entire year, where temperature maximum temperature sometimes goes to a 45-48 degree centigrade, and sometimes temperature lower down to 5 degree also, or 10 degree ambient temperature. Obviously, there will be some degradation will be different, and normally the higher temperature degradation will be more, and lower temperature degradation will be slower down. But it is not that ki composting is not possible at this temperature 10 degree. See, there are number of composting plant, and there are number of success studies available in the European country, where ambient temperature is 15 to 20 degree centigrade, and most of the time sometimes the temperature reduced to 0 degree also. Still they are able to run those composting plants. So, here you see the hot climate region, like in India, this is a favorable ambient condition. So, you can easily go for this is a one kind of technology, which again I am going to talk about in the next class, different type of composting technology. So, where you will see in the open area also we can do the composting process in the open area. Okay. So, and because it is a high climatic condition, so no issues will be come up, but only in the rainy season you can't have the such kind of composting method. So, like if you see in the colder region, what will be the problem? You are seeing here in this photograph, this excess water is coming out. This is the excess water, this is the leachate that is coming out, and problem is that now this is coming out means the mass will have more amount of water, then only the excess water will come out. So, if there is a more amount of water into the mass, so it is possible that this entire mass will go into the anaerobic condition, and I already sharing that is a composting is a aerobic process, and these leachate this excess water will come out only when the excess amount of moisture inside the mass, and in the case of only anaerobic degradation process. So, this is what the problem in the colder region. That is why I think most of the colder country they do not have the more amount of more numbers of composting facilities. Likewise, if you see in the hot climate region like South Asian countries, where temperature always temperature you will find more than 20-25 degree centigrade, that is one of the best temperature for the composting facility. Now, here you see here by this diagram you can understand that in the cold composting, so this is the mass, okay. This is a composting mass, and compost volume reduce, and this is the volume is remain after 6 months of composting period, and here mostly will be the coarse compost could be possible in the cold composting, and in the hot composting now is the same amount of mass will be required to add the oxygen into that, and within 80 days period we will get very large amount of compost could be possible, and that will be a fine compost. Okay. So, is less than 4 mm size compost will be able to achieve into the hot composting process. So, this is what the difference between the ambient temperature and the like in the India Obviously, the ambient temperature is in the hot condition. So, I think we need to have more composting facility. Already in the most of the schemes, I think composting plants are coming up, but I think problem is that is not only the only one parameter is required. Few more parameter is also affecting the composting process, and that I am going to discuss in the next slide. So, obviously temperature affect rate of composting. So, this is the temperature graph. So, which in the previous class also we have seen. So, here you see here this is the major one, the thermophilic temperature, and this chart indicate the phase when the removal of pathogen microorganism take place. This is the one, the thermophilic temperature, where these all pathogens, pathogenic microorganism will get removed out of, and the beneficial microorganism will be make spore, and they finally this same bacteria will growth into the those spore forming bacteria will be the in the active phase will be come up into the last phase of the composting process. Now, the next parameter is moisture content. So, almost all biological activity sees that moisture content lower than about 12%. So, this is also very important point. Please understand that any organic material, if moisture is less than 12%, is very difficult to see that the live microorganism into the that particular organic material. Take the example of agriculture mass, because the agriculture mass is more amount of lignin and cellulose percentage is there. Moisture content is lower, very low. So, that is why you will not see the very easy degradation of that particular kind of mass, because moisture content is very low into that. And a moisture content of 50 to 60% generally considered optimum for the composting process. Now, this is another very important point. The moisture content is 50 to 60% is a best for the or optimum for the composting process. And now, you see here in the composting process already temperature is rising, and because of that temperature rising also water will get vaporized. So, we know that thermophilic temperature is rise up to 65-70 degree temperature, and there also lot of moisture will get vaporized. So, there also the moisture content will removed out from the mass, but also while in the degradation also moisture will get produced. So, see this is very important to understand that how much moisture has to be maintained in the initial composting mass, that 50 to 60%, even you can go up to 70% also moisture content, but also need to see that how best you will be able to get the thermophilic temperature, so that the excess amount of water will get vaporized through the rise in the temperature, because while in the degradation also more amount of moisture will get produced. That is why you see in the colder region the excess amount of moisture is leached out from the composting mass, and along with that excess moisture content which is coming out from the composting mass, lot of nutrients will also removed out from the composting mass, which is required to find into the final compost product. So, microbial induced decomposition occurs most rapidly in the thin liquid film found on the surface of the organic particle. So, the organic particle is the very thin liquid film will be there, and where the microbes will be try to get decompose that particular organic matter. So, here these are the few different parameters, where the first is moisture content. Whereas, too little moisture less than 40% inhibit bacterial activity, and too much moisture more than 65% result in slow decomposition, odor production in anaerobic pockets, and nutrient leaching. This is the what I was discussing. Suppose if you have the low amount of moisture content like 30%, 40%, So, obviously, the degradation is possible, okay, but the growth of microorganism will be very slow. So, that will also inhibit the bacterial activity. So, your required composting time will be very high. In that case, you will be required 3 months, 6 months for the complete degradation of this organic material. And if you have more moisture content, like 70%, 80%. So, which what I was sharing, that the while in the degradation also moisture will get produced. So, it's possible that if more moisture will be inside the mass because of degradation also, and if you are not able to get the thermometric temperature, no vaporization could be possible, then it is possible that entire mass will be under the anaerobic condition. Because whatever the small pockets are there into the that particular mass, now initially there will be a air into the pockets, but after degradation process, if more moisture will be there inside that pocket, moisture will be there. So, obviously, if there is a moisture, the water will be there, means there won't be a air. So, obviously, that entire mass will be under the anaerobic condition. See, if there is an anaerobic condition, means there will be a odor production. I already talked about in the last lecture that in the anaerobic condition, methane will produce, ammonia will produce, there is a highly odorous gases, and also it will produce the excess amount of water that will leached out, and because of that lot of nutrients also will get leached out from the composting mass. So, it is very important to maintain the proper moisture content, and that is easy to maintain properly into the composting mass. So, often the same material that are high in nitrogen. So, this is also one very important point. The same material that are high in nitrogen are very wet. So, high in nitrogen are very wet, and those that are high in carbon are dry. So, this is very important point. You can easily see that where the more nitrogen is there in the organic material, that will be a very wet material. It means more moisture will be there, and where the more carbon is there, that will be in dry in nature. Okay. So, that also you can see that now here, if there is a more moisture, so how we can see the composting mass. So, very high moisture problem, and is a too wet. You can see here, the by hand you can see is a very wet material. Now, here in this case is a complete dry. In the both the cases, the proper degradation won't be possible in the both the cases. So, here you see that the optimum moisture content ensure proper microbial activity and hence the proper degradation of the waste. So, here I showed that moisture content, how it is changing. So, in the different composition of the waste material, you can see that how the moisture content is reducing, and this you will see here there won't be much changes in this one, because while degradation also moisture will produce. So, that also has to be see that the moisture content should be in the pocket of 50 to 60% or 65%. So, is a moisture content you can easily assess onto the field. This normally we can easily measure this moisture content in the laboratory. I think I can explain like this. You take 500 gram of composting mass or 1 kg of composting mass, measure the weight, note it down and put it into the hot air oven for 24 hours and see that how much moisture will get vaporized to the 24 hour, and again you note the weight of that mass, the whatever weight has been vaporized, that is your moisture content. You can, but in the field I think sampling collection you need to be go to laboratory to check the moisture content. So, if such kind of facility is not possible, you can easily do it into the field, like take the compost mass in your hand, and you see here the water, excess water is coming out. So, means I think this is not proper composting mass, this should be dry like this. So, as a rule of thumb, the material are too wet if water can be squeezed out of handful and too dry if the handful does not feel moist onto the touch. So, like in the two cases you can see here, when it has been squeezed, the moisture is coming out, but in this case even there will not be, you will see any water onto the hand. So, here this is the proper composting mass or degraded mass. So, is a too wet and here proper moisture content. So, what we are saying that it should be free flowing material, and then only you can say there is a properly degraded material. Now, the next parameter is a particle size. Now, this is also very important parameter because you take a example of in a large material, obviously the microbe has to be enter into that particular mass for the degradation process. If the size is big, obviously it will take more time to access inside into that particular material. So, that is why the size is also very important for the degradation process. So, microbial activity generally occurs on the surface of the organic material. Therefore, decreasing particle size through its effect of increasing surface area will encourage microbial activity and increase the rate of decomposition. So, now here you see that this is the small size. So, small size, how this we can show here, this is the composting mass, this is the organic mass, and whatever the pore space available here, this is free air space. Okay. Now, because here the air will be available and here the microbes will be degrade from the surface here. Okay. On the other hand, when the particles are too small and compact, air circulation through the pile is inhibited. This decreases O2 oxygen availability to the microorganism within the pile and ultimately decrease the rate of microbial activity. Suppose the size is too big, then the same the whatever the pore spaces availability, that will be smaller into the bigger size. Okay. So, that the availability of oxygen also will be less in that case. So, because of that, rate of microbial activity will be slowed down and degradation also will be slow in that case. So, that is why the recommended particle size is around 1 centimeter or small less than 1 centimeter, but again the another issue here, you can say that why only for the 1 centimeter, why not we will go for 1 mm size. So, that is easy for the microbial degradation. Now, the problem is now the same, suppose here the difference is 1 centimeter, okay, 1 centimeter. Now, the same material if you put it like this, like 1 mm size, 1 mm size material. Now, you see here the once the degradation will be there, the particle, what could possible in this particular pore space, that size will be very small, and whatever the size is available, rather than air, the water will be there, because of degradation water will also produce. So, that water will be into that particular pore. So, if there is a water into the pore, means that will go into the anaerobic condition. That is why the smaller size is also not that beneficial, having like 1 mm size or 2 mm size, if you make that particular material, and also for that you required very special kind of grinder or shader to reduce the size. But I think that is why the recommended value is 1 centimeter, and if you increase the size, obviously your degradation will be slower down. You see here, based on the diameter of that particular material, the degradation. So, is a day of decomposition. You see here the 1 inch diameter, you will see the temperature, the maximum temperature could be possible to achieve, but if you go for 2 inch diameter, your temperature, maximum temperature is also reducing, and if you have 6 inch of diameter, you are not able to achieve the thermophilic temperature in that case, because your degradation is very poor if the size is more. That is why the size is also very important that. So, wherever I personally visited the composting site, I never saw that the waste has been get shredded and proper size is maintaining in that one. But I personally believe that wherever the composting plant is available, need to have one proper shredder, and this shredder always that waste has to be come up through the shredder to the composting facility to maintain the size. Now, it is possible, like see in the from our household also in kitchen is not possible to get the same kind of size of material, especially the peeling waste, and that size sometimes goes to 2 centimeter, 3 centimeter, 5 centimeters, that size, and that has to be reduced down to the one particular. And if there is a proper shredded material, same kind of size material will be there. So, obviously, your degradation also will be improved in that case. So, this is what I was telling about, that we need to have proper shredding. Grinding is beneficial when raw material are fibrous like leaves, wood plants or cornstalk. And shading expose the greater surface area, making more susceptible to the microbial invasion. Shading material makes it more uniform in the size. So, this is also that if it is more uniform in the size aerate it and makes it easier to handle and keep moist. Fly control is also better when the material is pulverized or shaded. That is also one very important point, fly controls will be always there. And uniform compost made from the shaded material is easy for land application. So, final product also will be a fine material, that is very easy for the land application in the agriculture area. So, degradation increases when particle size is low. So, that is the final conclusion of this one. Now, the next parameter is a substrate. Okay. Substrate means whatever feed we are giving to the composting process, that called substrate. So, obviously, that should be organic in nature, but I think many time these discussions also is there, is it all organics could be possible to process by composting method? I believe that yes possible, but I think which is very difficult to get biodegradable for them is not acceptable for the composting mass. So, rather than organic, I think more biodegradable waste material is beneficial for the composting process. Although the ideal waste would contain all necessary nutrients, in the practice it may be necessary at times to add a chemical nutrients to remedy a nutrient deficiency. This is also one point where I think it is added to the nutrient available in the substrate, because if there is not much nutrients available and still we are looking for the composting process, like especially the agriculture mass or sewage sludge, if you are proposing that. So, there also some nutrient addition could be possible. That nutrient addition could be possible by addition of cow dung or any dung we can add to get the nutrients, and also some microbes could be possible to add into that particular degradation process. So, here you are seeing here the grass clipping, food scrap, leaves, that could possible to get utilized for the composting process, and especially the kitchen garbage, that is a maximum percentage in the MSW, that very easy to use for the composting process. So, the kitchen waste which is very highly acceptable for the composting process, which is having very high nitrogen in that particular mass. I think there only we need proper segregation, we need proper shading of that particular material, and easy to go for composting method. So, the combine the different kind of compost material yield a mix that compost well. So, now here it is possible. Now, see these kind of material like grass clipping, food waste, leaves contain low amount of nitrogen and more amount of carbon, whereas in the kitchen waste the more amount of nitrogen, less amount of carbon. So, it is possible by mixing both material together is possible to get proper mix for the composting mass. So, your substrate will be more beneficial for the degradation of bacteria or microorganism. So, here you can see here the different material could be possible to process through the composting process. So, especially for the kitchen waste or especially for the high nitrogenous waste, if you use the wood chips, this is also is possible. If you use sawdust, can be add to increase the carbon percentage into the mass. So, that is also more beneficial. Also, this sawdust is beneficial to reduce the moisture content into the composting mass. So, if you add these kind of material, so obviously we can easily maintain the moisture content also into the composting process, or even sewage sludge also could be possible to control the moisture content or to addition of more nitrogen, more carbon into the composting process. So, next parameter is a aeration. I think this is the one of the most important parameter in the composting mass. If you are able to aerate very well, so obviously the microbial growth also is possible to be very high, and if microbial growth is high, obviously your degradation also will be very fast. So, oxygen is the key element in the respiratory and metabolic activity of microbes. So, amount of oxygen required by the microbe is termed oxygen demand, and temperature, moisture content, size of bacterial population, availability of nutrients are some of the key factors that influence oxygen demand. So, here we were talking about that in the compost pile or compost mass, the whatever the pore space will be available, there the air will be get supplied for the growth of microorganism. So, the entire composting mass you can separate into the 3 different phases. One is the compost, that is the major amount water and free air space will be available into the that composting mass. So, obviously, while in the aeration process, the gases also will be come out. So, for the aeration process, we need to turn the material. So, that entire mass will be into the aerobic condition. Now, in this case, it is possible that the top layer will be always in the aerobic condition, the top layer, but after particular time period, maybe after 24 hours or within 2 days, this kind of material, the bottom material will be under the anaerobic condition, because whatever the air is available in the spores, that will be filled by the water is producing during the degradation process. So, now obviously, now this become the anaerobic condition. So, your odor will also get start into the composting mass. So, immediately you have to replace the material in such a way that these bottom waste will go into the top for the aeration process. Now, it is a highly aerated material will go into the bottom. By that way, if you turn the material every 2 days or every 3rd day, so the entire mass could be possible to aerate properly. So, this is what how turning and mixing affect the aeration and subsequently the temperature during the composting process. If the pile begin to cool down, the process start to become slower and will thus take longer. Okay. If the pile is turned, it begins to heat up and gets the process going again. However, it can also cool the pile down in order to prevent loss of nitrogen. So, adding new material to a pile can affect these two. New material can cool down the pile and will be behind the stuff that is already cooking. However, after a pile is actually up and running, it can easily absorb new material without necessarily being slower down. So, how the turning is affecting the entire temperature. So, if you turn the material, again the microbe will get lot of air. So, their growth will start up. So, your temperature will also increase, and after that it will also lower down. Again you turn, again it will increase the temperature. So, here now the addition of, here is discussion onto the addition of new material. So, what could possible that because already this is the degraded material, is already degradation is there into the mass. Now, we are adding the new fresh material into the composting mass. Obviously, it will reduce the temperature of the composting mass, but I think because this all is organic in nature. So, obviously, after particular time period the temperature also will increase. So, the compost mass pile is capable of reaching up to 70 degrees centigrade in just few days. Okay. So, here this is important graph where it is showing that days of decomposition versus temperature. So, if the temperature is very high, so you need to have turn every third day if you are able to get the very high temperature, and if you turn every 10 days your temperature will be like this, every third day temperature is lower down. So, you see here how important is the turning frequency. So, if you turn that composting mass in every third day, you will be able to achieve thermophilic temperature, but if you are turning at 10 days or 13 days, you are not able to achieve the thermophilic temperature into the composting mass. So, this turning also is very important factor, or the turning or aeration is also very important factor for the degradation process into the composting process. So, you can see here after 4 days composting, if you are turning, this is the degraded material inside the mass. So, if the pile gets too wet, can spread it down and or open a hole about 3 to 4 inch wide with the handle of the pitchfork and put stick underneath for the drainage. If the excess moisture will be there, that also is possible into the composting mass. The inside of the pile gets the hottest. So, if the pile is mixed frequently, the decay of matter will be more even. Okay. And by turning, oxygen is allowed to get into the pile, which will allow these microorganisms to breathe. It also decreases the chance of build up of anaerobic condition or anaerobic bacteria, which adds to a stinky compost. So, that is why in the field how to see that, when to do the turning, and how to know that whether that entire composting mass is converted into anaerobic condition. If there is a stinking odor into that mass, so obviously this stinking because of methane, because of ammonia gas. There is a major is the ammonia gas, and also some amount of H2S also could be possible. The small percentage is a highly odorous gas, highly stinky gas. So, by that way you will come to know that now the pile or particular material has to be turned. So, in the field how to know that? If there is a stinking, turn the pile. Again you wait for if stinking, then you turn the pile. In the large scale composting plants you can do that. And these microorganisms are obviously that there will be a bacteria, fungus and actinomycetes. Now, the next parameter is a nutrient or carbon to nitrogen ratio. This is also one of very important parameter for the degradation process. The ideal ratio is around 30, but many times is saying that is a 25 to 30 is the best optimum carbon to nitrogen ratio for the composting process. So, what is the benefit of that? Carbon is for source of energy and nitrogen is for building cell structure. So, you see here this graph is showing this is the time versus carbon to nitrogen ratio, where the carbon to nitrogen ratio is reducing. Why? Because carbon is degrading and nitrogen is increasing, okay. But the decrease of carbon is more compared to small increase in the nitrogen concentration. So, obviously, carbon to nitrogen will reduce, and if you are getting around 15 to 20 carbon to nitrogen ratio in the final product, that found to be a most suitable carbon to nitrogen ratio in the composting mass. If CN ratio of composting is in compost is more, the excess carbon tends to utilize nitrogen in soil to build cell protoplasm or robbing of soil. So, what could possible that if CN ratio is compost is more, so it is possible that whatever carbon is available, so more microorganism will be possible. So, they will be robbed the nitrogen from the soil. So, that is why is very important parameter to measure in the final compost mass, how much is the carbon to nitrogen ratio. If the carbon to nitrogen ratio is 25 or 30 in the final mass, and if you are putting that particular compost into the agriculture land, obviously their nitrogen they will be utilized for the further degradation of that particular material, that normally we call as a robbing of nitrogen from the soil. And if CN ratio is too low, the resultant product does not help the improve the structure of the cell. So, what will be possible that in the initially carbon to nitrogen ratio suppose very low like 10. So, what could possible, the carbon is less, nitrogen is more. So, the carbon means that is a source of energy, means the food for the bacteria is very less, and if nitrogen is more means there could be a more amount of microorganism. The microorganism growth is more because that nitrogen is required for their growth. So, now food is not remain. So, it is possible that this same bacteria rather than utilizing carbon as a source of energy, they will be used nitrogen as a source of energy itself. So, obviously, in the final product your nitrogen concentration will be lower down, and that process will also will be not that proper degradation can't be possible into that particular composting mass. So, here again this graph shows that days of decomposition versus temperature with CN ratio. So, you will see here CN ratio is 30:1 and 60:1. So, in 30:1 you will be able to achieve the thermophilic condition, but is carbon to nitrogen ratio 60:1, we are not able to achieve the thermophilic condition into that particular compost mass. So, now this material you will see is a very dry material, but organic in nature. So, material that are high in carbon are typically dry or brown material such as sawdust, cardboard, dry leaves, straw, bunches, other fibrous material, and their degradation also will be very slow. But whereas you see the green material that are high in nitrogen, typically moist green material such as lawn grass clipping, fruit vegetable scraps, animal waste, and that is possible to degradation is very fast in that case. So, this is what is another one. So, for the proper degradation process we will be required two part of the brown material or that dry material with the one part of green or wet material. Okay, and this is the another the same cases, these are the different wet materials, and this is different dry material or brown materials. By mixing of both we can achieve proper carbon to nitrogen ratio. This is another way, this is by that way different percentage is possible here to achieve. So, high CN ratio will lead to high degradation as more food, and low CN ratio will lead to fast degradation and formation of immature compost. So, you see here high CN ratio will lead to less degradation, means your degradation will be very slow, and low CN ratio is possible to have high fast degradation, but finally will get immatured compost. I think that does not have the more nitrogen into that particular mass. So, what could be possible that here I come up with the few different materials, okay, and carbon to nitrogen ratio or moisture percentage. Okay. So, if you take example of like rice or agriculture material, okay, which will have very low percentage of nitrogen, carbon to nitrogen ratio is very high, moisture also is very low. Okay. So, high carbon to nitrogen ratio, low in moisture, whereas you take the sewage sludge or even kitchen waste, you take example where nitrogen percentage is very high, CN ratio is low and moisture is high. So, low CN and high moisture. If you mix both the materials, now we will be able to come up with proper carbon to nitrogen ratio, and your degradation also will be very fast in that case. So, mixing the agriculture residue or kitchen waste can result into a good quality and mature compost finally. Now, these also sometimes questions will come, how by this mixing could be possible to achieve into the centralized composting facility in the different cities. That is what actually I never propose. I think this kind of factors is very difficult to maintain into the centralized facility. That is why if you go for decentralized facility where small composting plant, where this kind of parameter you will be able easily could be possible to achieve and to maintain into the composting. So, I think these are the very important factors need to be understand before going for the composting process. Now, I think you people have completely understood that how the temperature, moisture content, size, substrate, CN ratio is very important, and these parameter is not that difficult to maintain. The purpose of this lecture also, and you need not to have read to the lot of research paper to understand this factor. These we can easily achieve into the field by mixing two different material. To maintain the moisture, you take the wet material, some part, you take the dry material, mix it, and because of that not only moisture, your carbon to nitrogen also can be easily achievable, and because of that your thermophilic temperature also is achievable into the composting mass. So, I hope that you people have understood this parameter, and in the field also this parameter can be easily achievable. So, thank you for today's class.